Okay, so here we are with lesson 8.5. What we're going to do is we are going to be graphing quadratic functions and also writing down functions of these quadratics, given certain characteristics of them. And it's going to be in the form of intercept form. And we'll talk about that. Intercept form is that very first bullet point that's there on the screen. This is the form of intercept form. We've talked about two other different ones. We've talked about standard form, ax squared plus bx plus c. We've talked about vertex form, which is a times the quantity x minus h squared plus k. And now we're going into intercept form, which is a times the quantity x minus p times the quantity x minus q. And we'll get into what p and q stand for and what they represent. Here we go, a little bit of this core concept that you can find in the book. And this one goes into greater detail about what P and Q are. What we know is, from taking a look at this graph here on the right, what we know is that P and Q are actually the x-intercepts of our parabola. So if our parabola crosses the x-axis, that's where it would cross, at P and at Q. Now, mind you that this is x minus p. This is p is what you want to, is the number that you substitute into these equations, same as q. We can use p and q to find the axis of symmetry by finding the average of the two. P plus q divided by 2. That would give us our axis of symmetry. And just like on the other, when we were graphing the other quadratics, or graphing them a different way, A also tells us which direction it opens. If A is positive, it opens upwards, and if A is negative, it opens downward. So let's go ahead and start our first example. So our function here, graph, we are going to graph this function here where we have a negative sign, where A is -1. Our P, although it says x plus 1, before substitution, it was P was equal to a -1. Same thing with that 5. If you notice, it's x minus 5. It stayed negative from our original the function that we were given, x minus 5. That means before substitution, q equals 5. 5 was positive. Now let's go ahead and try and find the axis of symmetry. If we look back to our previous example, or that core concept, the way we find axis of symmetry is that we have to find the average of the two, the average of P and Q. So we'll go -1 plus 5 over 2, do a little bit of math, and what we get is that x is equal to 2, and we can go ahead and graph that. X equals 2 is a vertical line that crosses the x-axis at 2. Right, so therefore what we have is that x is equal, that our axis of symmetry is at x equals 2, which happens to be the x-coordinate of the vertex. Right? If we think about that, since this is the axis of symmetry, it's reflective across this line, x equals 2. That means that the x-coordinate can be found. That this is the x-coordinate of the vertex as well. Next, since we already have the axis of symmetry, we have the x-coordinate of the vertex, let's go ahead and find the y-coordinate of the vertex. Now the way we do that is, we know what x is, so let's go ahead and we're going to take x equals 2 and we're going to substitute it into our function. So a little bit of substitution looks like that. So f of 2, and then anywhere you see an x, you're going to put in or substitute in a 2. Do a little bit of math, and then voila, we got that. F of 2 is equal to 9. Now, what that gives us is, that gives us our vertex. It tells us that our vertex is at 2, 9. Right, so you go to the right 2, you go up 9. So this one, we go ahead and plot it, and we can find the zeros now. Where does this function cross the x-axis? Now, one thing that we want to think about is that negative side out in front. That means A is negative. It's going to be opening downward. Right? So now let's go ahead and find the zeros. just like that in that core concept at the very beginning, we can find our zeros by writing them as points. P comma 0 in parentheses and the coordinate pair Q comma 0. And that'll give us our x coordinates where this parabola crosses the x-axis. Now let's do a little bit of substitution. Now again, this is P prior to it being substituted. So that means it was a -1. After it was substituted into our function, it became x plus 1. Right? Q after substitution, it was a -5 before substitution. Q is equal to a +5. So these are our 2 points. These 2 points, this is where our parabola crosses that x-axis. Then what we can do is go ahead and plot these 2 points. Now we have an idea of the shape or how this parabola is going to be graphed. Okay? Another point that's good to find is the y-intercept. Okay? The y-intercept, that's where it crosses the y-axis. There's different ways of solving for it, but the way we're going to do it here is we're going to let x equal 0, because on the y-axis, what we know is that x is equal to 0, so all we have to do is do a little bit of substitution. Little substitution where x is equal to 0. So what we have is f of 0 is equal to, and then throw in the zeros or substitute the zeros wherever you see an x, do a little bit of math, and what you get is that 5. So f of 0 is equal to 5. What that tells us that's where it crosses the y-axis. So now what we would do is we'd plot that point at as well, 0, 5. The next step is what we want to do is a smooth curve right through all those points. Okay? Now, the y-axis is on the left. One of the things that we can do, though, is we can, since that point 0, 5 is reflected, we can reflect it across that x equals 2 line, and it ends up 2 units on the right of that axis of symmetry. That allows us to graph it a little bit easier. So let's go ahead and plot that, and then put a smooth curve right through all those points. Yep. Now let's talk about the domain and the range. The domain for all these quadratics hasn't changed. It's still the same. The domain is all real numbers. Okay? The range, that's the one that changes from quadratic to quadratic. We do want to use the y-coordinate of the vertex. In this case, the y-coordinate of the vertex, we found it to be 9. So that's the one that we want to use to write the range. Now, since a is less than 0, it has to be less than or equal to 9. So the range, just like it's written here at the very bottom, y is less than or equal to 9. And that's also what you can, one way to look at that is that the entire parabola is below that point, below that vertex.